Coming up on SciTech Now, making changes to keep students on the cutting edge.
I guess there's a need in our area to have students understand a little bit more of the engineering side of how things work.
A chair fit for dancing.
In 2001, I started working with dancers with and without disabilities integrated. That's when I really started thinking of the wheelchair as a creative instrument.
The art and science of brewing beer.
All of our brewing group managers, assistant brewmasters, and brewmasters, they all have technical degrees.
Funding for this program is made possible by the Corporation for Public Broadcasting, Sue and Edgar Wackenheim III, and contributions to this station.
Hi, I'm Mike Zeman. Thanks for watching SciTech Now. A Pennsylvania school is adapting, changing its curriculum to help students keep pace with a changing workforce. As producer Bill Hallman explains, the new lesson plan is already leading to new jobs.
That's going to be your paper size.
If you step into a classroom at Jeff Tech in Reynoldsville, you'll see some of this. Teacher at the front of the room, students at a desk. But stick around for a while, you'll also see plenty of this. Hands-on learning is part of the usual technical school curriculum. But times are changing. Technology is transforming the needs of employers, and Jeff Tech is trying to keep its students on the cutting edge.
Some days it is very difficult to keep up, but as long as you change with the changing technology, then it's a win for both parties. It's a win for the industry and it's a win for the students.
In Pam Kerr's shop, auto repair students are starting to get a handle on the complicated science involved in their future career.
I'm trying to take out some dents that my teacher put in here. You need to know how thick the metal is, how strong it is, what kind of metal it would be.
The kind of metal makes a big difference these days. Aluminum is starting to show up in more vehicles, and its thermal conductivity is about 6 times that of steel. That makes a big difference when it comes to welding. Now students at Jeff Tech are learning new welding techniques on newly purchased equipment.
Did you know it was this complicated when you started? No, I did not.
Just down the hall, Thomas Tinker, a drafting and design teacher with 21 years of experience, is also adapting.
We teach mechanical drafting, we teach architectural drafting, we get into civil drafting, and most recently, as of about a year and a half ago, we enlarged the program to include engineering.
The addition of engineering and new computer programs is all about one thing: job placement.
Employers are almost universally expecting that our students are going to know how to do 3D modeling.
Student Avery Nelson is already benefiting.
I actually do all the blueprinting for a company that provides services for oil companies.
Nelson is what the school calls a co-op student. Part-time in the classroom, part-time at a local employer, getting real experience and earning real money. But the students still in the classroom aren't falling behind. They're breaking the mold by breaking bridges. This bridge was Mr. Tinker's, but the students designed, built, and broke several of their own.
When you break a bridge, that's the only way to find out how much weight it actually held.
After each break, the students start problem solving, identifying weak spots, and examining the bridge for efficiency.
Your bridge was more efficient than mine.
Yeah, but mine only weighed 15
Avery's
grams.
was more efficient than mine.
Still
And Laura's was more efficient than mine by 1 point.
The school has lofty goals. 100% job placement for graduating drafting and design seniors. New technology is part of the plan, but so is critical thinking and the collaborative spirit of its staff and students.
Do you think you're teaching Mr. Tinker a good job?
For the most part.
For dancers with disabilities, traditional wheelchair designs can limit mobility and artistic expression. Science Friday brings us the story of a choreographer who's helping dancers to move in a new direction.
There's something very freeing about, basically having thoughts and ideas and human experiences that you can express through the physicality of your body. Freedom of expression, creating new movement possibilities, that's what we're always sort of exploring in dance. My creativity has always blossomed when I begin to work with physical objects outside the body. It's something about the relationship between the human person and the objects outside of that human body, especially working obviously with disability. My name is Mary Lynn Morris, and I'm the Assistant Director of the dance program at the University of South Florida. There's a tendency with disability for folks to think of the tragedy or the challenge, and that's not where the emphasis should be. That to also recognize that there's a lot of innovative potential and there's a lot of opportunity. From a personal experience, my dad had a disability, pretty severe disability, had a brain injury, and so that kind of brought me into more the world of disability. And then that experience has been layered with my work in the art world. In 2001, I started working with dancers with and without disabilities integrated. That's when I really started thinking of the wheelchair as a creative instrument, because the individuals I was working with had a lot of upper body mobility, and yet they were using manual wheelchair propulsion or they were using the joystick-controlled wheelchair. So it's been a long evolution. Started with exploring seat adaptations on Segways. Then later evolutions, as I worked with some other collaborators, moved into different places, and I began to sort of figure out for myself what the aesthetic of what I was trying to create was and why. Wanted the emphasis to be on the person and their movement, and a little different, a little unusual than your eye would typically identify as a wheelchair. My chair is different in two particular ways. One is the omnidirectionality. So the chair moves forward, backward, side, and diagonal directions and rotates and turns. The other thing is that the seat actually rotates independently from the base. So that's helpful for accessibility if you're talking about daily living, but also from dance, again, being able to actually spin the seat. It does have height change, and that again allows the individual to be at eye level, or in terms of dancing, it allows more change in the verticality. The other significant difference is the actual control system. So rather than it just being a joystick that's attached to the chair, my control system is a mobile control. So it's controlled through the smartphone, and so it can be held by the person in the chair. It can be worn by the person in the chair. So if you wear it, then when you lean forward, the chair moves forward. If you lean back, the chair moves back. If you lean to the side, the chair will move side. If you rotate this way, the chair will rotate. And the degree of movement, how far forward or how far back you lean or turn or twist, can all be programmed. The interesting thing, though, about this controller, which makes it just very different as offering another kind of possibility, is that you can have someone that's not physically engaged, not actually touching, the person, and they can yet be still controlling the chair. Through their movements, potentially their own movements, they could be dancing over here and controlling the movement of the person over here at a distance. There's this kind of empathy, there's an empathetic connection there. And so in some ways that it kind of embodies this idea that even though we're apart, we're actually still really affecting each other. I'm in dance, I'm a dancer, and I'm a dance creator, So the chair, I hope to use it in a dance context. But I've always kind of had my eye on the pedestrian aspect too, which is the sort of daily life aspect as well. So in the manual chair, you can't really talk to someone who's behind you. So in the case of my chair, wouldn't necessarily, for instance, have to be behind the chair pushing. People want to hold hands or connect physically a little bit with their bodies. You can connect hand to hand and simply walk together. So the chair is therefore sort of a blend of the sort of aesthetic, creative, and this kind of more functional, the sort of daily life aspect as well. I think that if it's more conducive for people to come together, to physically connect, and that if it encourages that in some way, and certainly to dance together, that it heightens emotional connectivity. That's very exciting. I mean, that's very joyful.
Following the 2016 presidential election, many voters are looking for ways to stay engaged in the political discourse, and some startups are leveraging data and technology to help. Maria Yuen is the CEO and founder of one such endeavor, an online platform called Issue Voter. She joins us today to discuss the role of technology in fostering civic engagement. So what is Issue Voter?
So Issue Voter is a site that lets you get alerts when your congressperson is about to vote on a bill related to an issue that you care about. And we summarize the bills, offer what the proponents and opponents are saying, along with related news. And then one click sends your opinion to your elected official's staffer. And you have a profile on the site that tracks throughout the year how often your congressperson is voting how you would want them to vote on issues you care about.
So this is kind of like one of those little cheat sheet guides that you take into the polling booth. Maybe your local paper said, you know, if you're a progressive or if you're a conservative, this is where you should be on these issues and so forth, right?
Similar. It's nice because you can keep all of your issues in one place as opposed to looking at several different organizations and their scorecards and trying to somehow triangulate that. So it becomes a really personalized guide because it's literally the bills that you've actually sent your opinion on, and then you can see what that outcome was. So when Congress votes, you would get a notification that shows you this is what you voted, this is what your rep voted, and here's whether or not the bill passed.
This is the modern day version of the phone call or the letter writing campaign.
Exactly.
Yeah. So how does this technology improve that experience, right? So does the member of Congress, are they more or less likely to be aware of how citizens in their constituencies, in their neighborhoods, in their backyards are actually thinking about these issues?
I think that the nice thing about technology is it enables a lot more people to be heard. So a staffer can only take so many phone calls in an hour or in a day, and this is a way for more people to participate. So our mission is to give everyone a voice in our democracy, you know, by making civic engagement accessible, efficient, and impactful. I would say that by sending it electronically, there is still some resistance depending on the rep, to be honest. I think some reps and some really advocacy organizations oftentimes encourage people to make phone calls, but I think eventually we are going to move beyond that. For example, you know, when you order your food online or by going to the restaurant and picking it up or eating at the restaurant or picking up the phone, like no matter what way I order my food, I still want it to taste good. Right. And so I think more and more reps are realizing no matter what medium you use to communicate, it doesn't mean that your opinion matters more or less.
What is the kind of the back end gain? I mean, yeah, you said impactful. So how do you make sure that this is sort of action oriented, right? That people don't just study the issue, but they're telling their reps.
Well, we make it really easy to do that. So we give people alerts that there's even something to tell their rep about in the first place. And then it is literally one click to send the opinion. So that is the action that we want people to take. And so far we've sent over 20,000 opinions to Congress and in just a short matter of time. And so we've also had a lot of staffers reach out to us to get connected with their constituents and ask about, you know, Issue Voter.
Is there a benefit to having that data of when somebody's opinion is a certain way about something? So are they going to be targets if I say that I am pro or anti-gun control or choice or whatever it is? Am I going to get targeted by different ads saying, hey, you should change your mind or you should think about this? Or how do you work in that arena?
So we're not selling the data right now.
Right.
And what I would say that, you know, from the rep's point of view, they do have staffers whose job is to count every constituent contact. So when you say impactful, that's the main impact that we're trying to have right now, as opposed to, for example, a petition. So we see a lot of petitions. The problem with petitions is that to an elected official, it's merely a list of names. And often petitions for political causes don't actually work. And there's a number of reasons for that, but I think that the biggest thing that we can do is send the opinion directly to that person's rep who's actually elected to represent them. As far as how the data is being used, it's something we're still working through. So we're relatively new.
Yeah.
We launched the day after the election, so it's been a little bit over a month.
So what do you need to do to get to scale? You know, technically speaking, there are already phone lines everywhere in the country and people know how to put something in the mail and reach their rep. What's the critical mass that you need to hit when all of a sudden members of Congress say, you know what, this is another medium where people are going to reach out and tell me how they think about things?
So I've spoken with former Congresspeople and current staffers, and generally kind of to triangulate the different responses and conversations, they say anywhere between 1,000 and 5,000 people it becomes interesting.
Okay.
So it's not necessarily millions and millions, and because unfortunately, less than 5% of constituents are actually reaching out to the reps currently.
So are you hoping to change that by making it easier?
Definitely. Yeah, that's definitely our goal.
One of the things that people forget about this election is how few people actually went to the polls. I mean, less than half the population or so, right, actually use the rights that they have. So how does technology change that? And if you can get people engaged now through the midterms, maybe an increase in people that actually turn out?
Yeah, exactly. I mean, I think by seeing these alerts throughout the year, it will help people realize the work that's actually being done and the importance of voting. Because we hear about a couple issues in the news, but we don't necessarily see the hundreds of bills that are being voted on every year.
Maria Yuen, issue voter. Thanks so much.
Thank you.
A biotech company is using spider DNA to transform silkworms. The result? A fiber that's tougher, lighter, and more flexible than just about anything on the market. Here's the story.
In a nondescript metal frame building in an industrial park in Charlotte, the ultimate textile target may finally be reached.
These are all cocoons from silkworms. Okay. They're ordinary, standard silk that we keep here for testing, but it's the same. So this fiber is, as you can see, a lot thinner than the hair on your head. But this is a mile long inside this cocoon.
A mile?
A mile long of a continuous fiber.
The target is silk. It has been collected like this from the cocoon of the silkworm for thousands of years. The material is prized for its beauty and its texture, but these are not the typical silkworms.
This one right here, one of the parents tested out at full strength spider silk. So I have great hopes, and they just hatched this morning.
Did you catch that? Spider silk? Keep watching.
We're taking the black widow gene and putting it in place of the silkworm silk gene. And so when they go to make the cocoons, they read the gene and they just make it. And instead of making regular silk, they make spider silk.
You heard correctly. David Brigham is producing spider silk from silkworms. But the black widow produces a silk that is stronger and stiffer than most spiders. Brigham implants the gene that controls the production of spider silk into the silkworm.
That's right. They eat mulberry leaves, grow big and fat. They spin a cocoon, and then they start turning into a moth. They go to pupa, and they would come out as a moth. We interrupt the process to pull all the silk off their cocoon and make yarn and fabric.
You could call it agricultural alchemy. Since silk is a natural protein fiber, putting the spider gene into the silkworm transforms the worm into a kind of protein factory for spider silk. The silkworm doesn't change, but thanks to genetic engineering, it's just making a different silk.
The engineered silkworms, which we tested to see if they had the spider silk gene, and they did, one copy. So now we're breeding transformed silkworms together so that we have offspring that have 2 copies of the spider silk gene and are full strength. To loosen up the protein glue that's holding that fiber together is we're going to put it in hot water.
But beyond the high-tech genetics, spider silk cocoons are still processed in essentially the same low-tech way the cocoons of silkworms have been processed for thousands of years.
So we should have loosened up the glue enough in this very hot water to be able to swirl around and find that one end that goes all the way through. And there they are. So we're now unreeling the silk. The way you work it, this one thread is, well, this is not really very thick enough to really actually run through a textile mill. So what you do is you put, depending on how fine a fabric you're making, 10 or 25 together to make a thicker yarn.
The cocoons, with the ends of the fibers now exposed, are brought to a textile mill reeler. The tiny fibers are then combined, one by one by one, and loaded onto the mill, where they are automatically unwound.
We're making yarn. And so when this runs out, what you do is just grab this and throw it under, and it automatically takes up another one. You just keep going until you fill the reel.
By now, you're probably asking, why exactly make spider silk?
Spider silk is 5 times tougher than Kevlar. It has not as much strength, but it has stretch, so it's very, very tough. And my favorite analogy is a plate glass window and a trampoline. You put Nolan Ryan in front of a plate glass window, and you're pretty safe for a while, but eventually he's going to throw a fastball hard enough it's going to break that window, and then you have no protection. But nobody throws a fastball through a trampoline. Kevlar, Spectra, those are plate glass windows. Spider silk is the trampoline.
The military is searching for a material that is not only strong but also more elastic and lightweight. Brigham's creation has already undergone ballistic testing. It passed until the most extreme of tests.
They kept upping the powder charge in the bullet until they defeated it. They wanted to know how fast a bullet could go before it came through.
The fiber could also be used in a host of medical applications, such as sutures, implant coatings, or even artificial tendons. That's because the human body doesn't reject spider silk.
I'm seeing a soldier writing me a letter saying, I'm home because I was wearing your spider silk vest, and that's why this business is here.
Homebrewers and brew pubs are pushing the boundaries when it comes to craft beers. But some of the country's biggest breweries are using science to stay on the cutting edge. Reporter Anne-Marie Berger takes us behind the scenes of the beer brewing industry in St. Louis, Missouri.
In 2015, the beer industry in the United States saw more than $100 billion in sales. This includes craft, imports, and the largest in volume, domestic beers. Anheuser-Busch topped the charts at #1, and while AB is loyal to their flagship beers such as Budweiser and Bud Light, they do invest a lot of resources in experimenting with new beers.
So what kind of beer is this?
So this is the Oatmeal Stout. This is our Project Training Day. This was made in the Research Pilot Brewery.
The Research Pilot Brewery, located at Anheuser-Busch headquarters in St. Louis, is where up-and-coming brewmasters are trained, future innovative beers are developed, and raw materials testing is done.
We started with the grain like this, and if you'd like to try it, you can. It tastes like just like a cereal. It's sweet, it's a little crunchy. So this is malted barley.
Rob Naylor is brewmaster at the RPB.
So we'll get hops in from Washington or Oregon or in Europe, and we'll do some single hop tests. So we'll actually brew a beer with it because we want to know, what type of bitterness does it give us, what does it really taste like, and then we also want to see what the aroma is.
Beer can be many things. It can simply be a beverage, a hobby, a social icebreaker, or all the above. But first and foremost, the art of brewing beer is a science.
All of our brewing group managers, assistant brewmasters, and brewmasters, they all have technical degrees, typically electrical engineering, mechanical engineering, chemical engineering, chemistry, biology, or food science.
Like all sciences, beer brewing requires accuracy and patience. And this process starts with milling, or crushing, the grains.
So what we're going to do is we're going to crack the husk, and then we're going to try to expose that endosperm that's in the middle. That's where we're getting a lot of our extract. We don't want to pulverize the grain.
The goal is to reveal the starchy barley seed without crushing the husks that encase them. If the starch is too coarse, the fermentable sugars will be affected. If the husks are too fine, the filter bed will be ruined. And you can't have that when brewing beer.
They're so small.
They're so small. So what we're doing right here is 2 big rollers that are coming together, and they're pushing the...
Oh, out.
Yeah, they're
squeezing it out.
They're squeezing it out.
Got it.
From there, the milled grains are combined with water in the mash cooker.
And what's actually happening is we are converting our starches to sugars. So the longer we convert starches to sugars, the more we're going to get more fermentable sugars, and then we'll be able to get a kind of a lighter, low-carb beer. We'll also be able to get more alcohol from there. The shorter time, there will be less fermentable sugars in there, and it'll be more non-fermentables, so you'll get more body and a heavier beer here.
In this process, temperature is key. Naylor explains it will mash in at about 109 degrees. raising the temperature releases the enzymes.
And that's when we're actually going to be creating different beers. And that's one of the main things where you're looking for consistency. This is something that we can do. We can make sure in our mash cooker we are consistent. We know exactly what temperatures we want to hit, so we'll get the right fermentable sugars and hit the right body and the right alcohol and the right color.
The ground up grains in the mash are extracted through the lautering process to create the wort.
From there, we'll actually take it into our brew kettle, of which we will bring up to a boil, and we'll add our hops. Now, our hops are what are going to add the IBUs and kind of the spice of the beer. They'll also give you the aroma depending upon when you add it. We add our bittering hops at the very beginning of boil, and then we will add more of our aroma hops towards the middle and end of our boil. At this point, we are transferring it to one of our fermentation tanks. As we're filling, we start transferring our yeast. We use different types of yeast. We'll use ale yeast and lager yeast, and then we'll be able to maintain it at a certain temperature.
While some brewing in the RPB is strictly materials testing, there's always the chance the next big beer could be discovered.
How many of these actually make it to market? Because it's a big deal for Anheuser-Busch to put out a new beer.
Yeah, well, so, the Research Pilot Brewery has been around since 1981, and, one of the first beers we came out with was Bud Light. So I always look at it that it's a giant shoes to fill to come up with the next Bud Light. But, all of the Shock Top beers, the Michelob series, Platinum, all of those beers have come from the Research Pilot Brewery.
This is one it's been up for about a week, and we're getting some really positive reviews. So this may be one.
I like it.
You can watch full episodes of SciTech Now on demand or online at wpsu.org/digital. I'm Mike Zeman. Thanks for watching.
Funding for this program is made possible by the Corporation for Public Broadcasting, Sue and Edgar Wachenheim III, and contributions to this station.